Welcome guys. Our next topic and the last topic for this module is quadratic form. So homogeneous second order polynomial with different number of variables is known as quadratic form. Simple, it should be homogeneous second order polynomial and different number of variables. That is called quadratic form. So x square plus y square plus 2xy is your quadratic form with two variables x and y. Now ax square plus by square plus cx square plus 2g xy plus 2fyz plus 2hxz is with three variables, that is x, y and z. Now what I can write x square plus y square plus 2xy in terms of matrix as this. This is called indexing. You must have read about this. How I can write this equation in terms of matrix? So keep this in mind. So x square coefficient is right in this place, y square coefficient in this place, z square coefficient here, and the coefficient of xy is 2g, but we divide by 2. This is a formula, it will get clear. I'll explain in one example, but just have a look at this. Now we should learn about basic terminology. So what is rank? You will given a question and there it will be mentioned find rank, index, signature of the given matrix. So what is rank? Rank of a quadratic form denoted by R is nothing but number of non-zero eigenvalue. Suppose say we find matrix A and whatever we get the eigenvalue, and that eigenvalue, that non-zero eigenvalue is the number of rank. Say suppose if we find eigenvalue for the matrix as 0, 2 and 3. So what will be the rank of the matrix? It will be 2 because there are two non-zero terms, that is 2 and 3. Now what is index? Index is denoted by P and it is number of positive terms in eigenvalue. Example, say suppose eigenvalues are -2, -3 and 1. So what is index? It's 1 because we have only one element with positive term, that is 1. Signature is denoted by S and it is number of positive terms minus number of negative term. That is, whatever the number of positive value, will subtract that by negative term. See this, ay square plus by2 square plus cy3 square. So rank is what? 3. Why? Because the number of non-zero eigenvalue will be 3 and P, that is the number of positive term in eigenvalue, will be 3. S is signature, which is number of index P which will be 2 because there are two positive term. A is in minus. Signature is number of positive term minus negative term, which is positive term is 2, negative term is 1, so 2 minus 1 is 1. There is one more formula for signature. Note this down. Signature equals to 2p minus r. P is index, r is rank. Coming to nature of quadratic form. So if all the eigenvalues are positive, then the nature of quadratic form is positive definite. Take care. If all the eigenvalues are negative, then the nature of quadratic form is negative definite. If one or more eigenvalues are 0 and all other are positive, then the quadratic form is semi-positive definite. If one or more eigenvalues are zeros and remaining are negative, then the nature of quadratic form is semi-negative definite. If some eigenvalues are positive and some are negative, then the quadratic form is called indefinite. Example, 1, 0 and -1 because it has both positive as well as negative. Let's go through one example quickly. Write the matrix in quadratic form. So this is the matrix. This is given. Now we need to convert this into matrix. So first of all, we'll convert this quadratic form into the matrix form. How to convert this? This is the formula. Note this down. This is very important. There should be in this place it should be coefficient of x square 1 by 2 coefficient of xy, 1 by 2 coefficient of xz, 1 by 2 coefficient of yx, coefficient of y square, 1 by 2 coefficient of yz, 1 by 2 coefficient of zx, 1 by 2 coefficient of zy, and coefficient of z square. As you can see, coefficient of x square is 2. XY coefficient is this 2, so 2 divided by 2 1. So in this way we have made this matrix. So keep this in mind, like note this down. Now reduce the quadratic form this into canonical form. Again, this is very important question. Like this quadratic form is given and we are asked to convert it into a canonical form. Also find rank, index, signature and the nature. I have taught this earlier. We'll see through this example. So there is a, like, we will first convert this quadratic form into a matrix applying this this formula. So we'll get this. It's 3 minus 1 minus 1 5 minus 1 1 minus 1 3. You can match this using this. Okay. So now again, y a minus lambda I equals to 0. So it will be lambda cube minus lambda 11 lambda square plus 36 lambda minus 36 equals to 0. So we'll get 3 lambda value 236. Find eigenvector corresponding to this lambda value 2 and then 3 and then 6. You will get 1 minus 1 0 1 1 1 1 and 1 minus 2 1. Now make model matrix P, and this is normalized model matrix, which is writing the corresponding eigen vector of the eigenvalues along with denominator as their determinant. Okay. Now find P transpose into A. Find P transpose A into P. You will get this diagonal matrix with diagonal element as the eigenvalue of the matrix A, that is 2 3 and 6. Now it's very easy. Just reduce this into a quadratic form, and with that will be called canonical form. What is the, if we will write it in the form of normal quadratic equation, what we will write? 2x square plus 3y square plus 6z square. So this is your canonical form. Keep this in mind. Okay. And again, if we find the rank, so what will be the rank of this? So number of non-zero rows in D. So here we take reference of this diagonal matrix. So rank is 3. Why? Because number of non-zero rows in D. So number of non-zero rows is 3, because no any row is completely 0. So rank is 3. Nature is positive, definite, because what I have taught about positive, wait, let us see here. If all the eigenvalues are positive, then the nature of the quadratic form is positive, definite. So here, as you can see, all the elements are positive, so it is positive, definite. Index is 3. Why index is 3? What I have taught. So index is your number of positive terms and eigenvalue. So positive terms is again 3, so index is 3. And signature is 3. Signature is number of positive terms minus number of negative terms. So positive term is 3 and negative term is 0. So 3 minus 0 will be 3. Here is an exercise problem for you. Apply the same process for the last I have applied in the last question, and reduce the quadratic form this into canonical form by orthogonal transformation. Orthogonal transformation by model matrix, finding P, then P transpose into A, then again P transpose A into P, then lending to diagonal matrix D. And also find rank, nature, index and signature. So I have given hint. This is matrix A. This is your eigenvalues, this is your model matrix, this is your P transpose A into P, and this is your canonical form. This is your rank, nature, index and signature. Okay. So I hope this topic is clear. So with this we come to end of our module. I hope you enjoyed learning from me. So thank you.